All right, hello again, everybody. So this is actually the last section that we're going to cover in this algebra application unit in applied math. And the last type of problems we're going to do, we call these mixture problems, where we're mixing together two types of substances, we can call them. You know, we have some examples where it's juice, another one where it's like mixed nuts. And one of them is a certain percentage of one flavor, another one is a certain percentage of another, and we want to combine them together to be this particular percentage with both of them combined. So how does this work exactly? So I always like to set them up this way, where you're basically looking at the containers. Notice I just drew out the containers. So we have brand A fruit punch, which is 10% fruit juice. So I just have a container here where I just have a 0.10 underneath it to represent 10%. And we're mixing that with 3 liters. That's at 40% for brand B. That's 40% fruit juice. Now we know we're putting 3 liters into that. So I'm going to put a 3 in that container because we know we're putting 3 units into that. And when we mix it together, it's going to contain a total of this mixture that is 20% fruit juice, right? So how much goes in each? Well, the question is asking how much are we putting in the first one at 10%? That's what we don't know, so we'll just say that we're putting X amount in there, right? We don't know how much we're putting in there. That's what we're trying to figure out. So we'll say X amount is going to be 10% fruit juice, and then we're going to combine it with 3 liters. So that means our third container, when we combine them together, is going to be this one plus this one. So in this container, it's simply going to be X plus 3. Okay? So this is what we have to set up. And really what we have here now is just a simple equation. You're just going to take whatever number is these percentages that are underneath the containers. We're just going to multiply them by whatever is inside the containers. So 0.10 times X plus 0.40 times 3 will equal 0.20 times, and I got to put in parentheses here, X plus 3. Okay? All right, now, if you want to make everything a little bit easier on yourself here with these, you know, we don't have to keep these as decimals. So one option that you do have if you want is you can just multiply this whole thing by 100, because what that does is it pretty much just moves the decimal 2 places to the right, and now you're just basically dealing with the numbers that they were when, you know, before we made them decimals. I just had to make them decimals to remind us that we're talking about percentages. Now, that's only going to affect these decimals. The stuff in parentheses does not get multiplied by the 100. So after we do that, notice what happens. We just get this as our equation, which some of you will notice looks a lot nicer now because, you know, we don't have any more decimals. Now, this is a little bit more elaborate equation than the ones that we've done the past couple of classes. But again, most of you should still be pretty well versed in your Algebra 1 skills. This is also something you had if you've all had at least Algebra 1. But I'm going to go through this again just in case. The main thing here is that notice we have variables on both sides of the equal sign. So we got to get all the variables to the same side. But first, let's clean it up. Right? We know that 40 times 3 is 120. And then here, remember, we have to apply the distributive property. So we have to take 20 times x to get 20x, and 20 times the 3, which is 60. Okay? And now that we have that equation written out, we can now solve for our x. Now, again, you want to get all the variables to the same side, so it's kind of up to you if you want x to be on the left or the right. I typically like to keep x on the left side. So what I'm going to do is I'm going to subtract 20x, which means I have to subtract 20x from here. Okay? So that results in negative 10x plus the 120 is equal to 60, right? Because over here it canceled out. And now notice we're looking a lot like the equations we saw in the last lesson, where now we just solve for x. We subtract the 120 from each side. And 60 minus 120 should be negative 60. And then we would just divide both sides out by negative 10. and as a result we get 6. So the answer would be 6 liters is how many we would put in that first container. So 6 liters would go in at 10%, combine that with the 3 liters at 40%, which will be a total of 9 liters at 20%. But of course all we care about is how much is going in that first container, which is 6 liters. Okay? All right, I'm going to do another one here with you guys, and then you guys are going to try 2 of them on your own. Okay? So here's number 10. Again, I already have the container part set up. So here we're mixing, looks like mixed nuts to make some sort of a trail mix or something. They say how many pounds of mixed nuts that contain 70% peanuts must Amanda add to 6 pounds of a mixed nut container that's 40% peanuts to get a total mixture that is 60. So again, we know we're putting 6 pounds into the container that's 40% peanuts. So 6 goes in there, and we're trying to figure out how many is going at 70%, because that's what they're asking. So we know the total amount will be the x plus the 6. All right, and then this problem is set up the same way. Now if you want, when you multiply these numbers by the containers, if you want to move the decimal at the same time, if you think that'll save you a little bit of time and space on your paper, that is perfectly fine. You can do that. Okay? So notice I went ahead and just moved the decimals back, and yeah, it's we write them as decimals just to remind ourselves that's what a percentage is. But in any event, it doesn't matter because we're just going to move them back anyway. And now we're ready to solve this equation. Again, first let's clean it up a bit. We have to multiply here to get 240, and then distribute the 60 here to get 60x plus 360. Okay, and then once again, this is, just like the last example, variables are on both sides of the equation. So again, I like to get the variables to the left, so I'm just going to do what I did on the last one. I'm going to subtract 60x. Then I go ahead and continue, do the rest of the algebra. Next, I got to subtract the 240 from each side. So 360 minus 240, which would be 120. And then if we divide both sides by 10 as our final step, we get that our x is equal to 12. So it looks like it's going to be 12 pounds is how much is going to go in to the container that is 70% peanuts. Okay? All right. There are 2 more for you guys to try. Pause the video and try number 11 and 12. Set it up with the containers like I did, and then we'll take a look at these together. Okay, so let's see how we did on numbers 11 and 12. So here's the initial setup. How much of brandy? Again, we're back to the fruit punch. It's going to be at 40% fruit juice. So again, that's what we're trying to figure out, X amount. That's going to be at 40%. But again, they put 3 liters in at 25%, so put a 3 in there. And together, that's going to be 31% fruit juice, so the X plus 3 is what goes in there. This one's a lot similar up here, at least to number 11, but the percentages are different this time. All right, so again, if you want to move the decimal and set up the equation all in one step, I recommend do that. Okay, so there's my equation set up there. All right, let's clean it up. So let's see, we multiply 25 times 3, I believe, is 75. And then distribute the 31. We get 31x plus, I believe, 93. Okay? And then continue, variables on both sides. So get the variable to one side, subtract the 31x from each side. So let's see, I believe this is going to be 9x plus 75 equals 93. And then we subtract our 75 from each side. So 93 minus 75 gives us 18. And then we divide both sides by 9, and we should get that x is equal to 2. So it will be 2 liters will go in at the 40% fruit juice. Okay, 4 liters of the fruit punch of Brandy. All right, so if that is what you got, very good. If not, go back and double check all your work here and see what you did. All right, and let's take a look at this last one here. Back to the peanuts example. How many ounces of mixed nuts that contain 70% peanuts? Again, that's what they're asking. So X amount is going in there. Must JD add to 19 ounces? So she put 19 ounces in at 40%, and both of those combined will be 51%. So there's our initial setup there with the containers. Okay, and now let's go ahead and set up our equation. And again, you can move the decimal at the same time you set up your equation. So 70x plus 40 times 19 will equal 51 times x plus 19. Okay, so let's see. Well, we got 70x plus, let's see, 40 times 19 is 760. Distribute the 51, you get 51x plus 760, it looks right. Oh, no, wait, I'm sorry. Nope, that is incorrect. I was not thinking. 51 times 19. Hold on, guys. 969 is what I meant to say. There we go. Okay. All right, so there we are. I apologize for my little mistake there. Okay, so now, again, same thing. Let's just get all the variables to the same side. Again, I'll just keep doing what I'm doing and subtract, get the variables to the left side. So subtract 51x, 19x, plus 760 equals 969. Subtract the 760 on each side here. We get that 19x is equal to, let's see, 969 minus 760 is 209. And then last step would be to divide by 19. So let's see, what is 209 divided by 19? Should be 11. So 11 ounces is how much is going to go in at 70%. So 11 ounces going into that 70% container to get what they need. All right. So this is the last of the algebra application unit here. So there are 3 types of examples that we can use algebra to solve, and I hope they've all worked out pretty well for you guys. So go ahead and do the last group of problems that are on that homework worksheet. It should be numbers 13 through 18. That's all the rest of them. Tomorrow, you guys will want to finish up the whole thing in I believe you'll be provided a Google form at that time where you'll just submit your answers to the whole thing. It's just going to be one big homework assignment with all 3 of them. And then I believe you guys should have a review coming up like I had mentioned before. As I'm making this video, I believe that is still the case, but everything will be posted on the announcements on Google Classroom if I need to correct anything I'm saying here. But yes, a review will be coming up, and then we'll look at that whole review when I return. Again, I'm hoping to be back after we return from spring break, and we'll be able to review all this stuff at that time. If you have any questions, feel free to just let me know, and I will see you guys all later. Everybody take care. Thank you.